So in this video, I'm going to go over the Unit 7 test review, which is on volume. So first of all, number 1 says find the area of the figure below. I notice that this is a triangle, and the formula for a triangle is on our formula sheet. It's 1/2 base times height. Notice that 27 is the base, and we know that this 16 right here is the height because it's a right angle to the base. So our area is going to be equal to 1/2 27 times 16. So our area here is going to be 216 centimeters squared because we're going to multiply those three values together. 1/2 times 0.27 times 16. Number 2 says find the area of the figure below. The first thing I need to realize is that this is a trapezoid because it has a pair of parallel sides and it's a quadrilateral. The formula for a trapezoid is area is equal to 1/2 the height times base 1 plus base 2. So the first thing I want to notice is that, again, this is my height because it's a right angle to the base, and my bases are our parallel sides. So the formula here is going to be, again, 1/2 of 32.7 times base 1 plus base 2, so I'm going to do 38 plus 13. So I'm going to break this down another step. 1/2 of 32.7, and then this would be 51. So when we do that, again, in our calculator, 1/2 times 32.7 times 51, our area here is equal to 833.85 meters squared. And again, remember that when we're talking about our units in its area, then our unit is going to be squared. Number 3 says a rectangle has an area of 228 feet squared and a length that measures 12 feet. Find the perimeter of the rectangle. So the first thing I want to talk about is the formula for the area of a rectangle. It can be base times height or length times width. I'm going to do length times width. So area is equal to, we have the area. It's given is 228, so we're going to put that where the A was. And then we're given that the length was 12, and that means we're going to solve for W. So we're going to divide the 228 by the 12. And when we do that, we get that W is equal to 19. Now, the other part of this problem that we need to realize is that it says find the perimeter of the rectangle. Well, the formula for the perimeter of a rectangle is 2 times the length plus 2 times the width. So we have both of those. So our perimeter is equal to 2 times 12 plus 2 times 19. So when we do that, we get that our perimeter is 62 feet. So for number 4, find the exact value of the side of a square whose area is 128 inches squared. So again, we need to know our formula for the area of a square. That's area is equal to side squared. So we're going to put this area here, 128 is equal to side squared. We're solving for a side, so that means we're going to take the square root of both sides. So we're going to take the square root of the s squared, and we're going to take the square root of the 128. When we do that, we get s here, and we get the square root of 128 here. So I'm going to move this over here, and we're going to work with it here. So the square root of 128 is equal to s. So now we need to factor this. I know that 128 is an even number, so I'm going to start with the 2 here. So I know that 2 is a factor of 128, and if I divide 2 into 128, I get 64. Well, I know that 64 is a perfect square. So what I'm going to do now is I'm going to take the square root of both of these, and the one that can be simplified is the square root of 64. So our answer is going to be for our side is going to be 8 square root of 2, because again, the square root of 64 is 8. So number 5 says a circle has an area of 76.97 kilometers squared. Find its diameter. So we need our formula for area of a circle. That's A is equal to pi r squared. So area is 76.97. So we're going to put that where our A is. And that's equal to pi r squared. So we're going to divide both sides by pi. And when we do that, we get 24.5 is equal to r squared. And obviously at this point, we're going to take the square root of both sides. And when we do that, we get that r is equal to 4.95. Hopefully all of you know that a diameter is equal to 2 times the radius. So we're going to do 2 times 4.95. So our diameter is going to be 9.9 kilometers. All right, number 6 says find the area of the shape below. Well, first thing I want to point out to you is I noticed that I've got a half circle over here and a half circle over here, and those two half circles make a whole circle. So I'm going to use the area of pi equals pi r squared for the area of that circle. I also noticed that my diameter here is 7. So to get the radius, I'm going to divide that by 2. So that means my radius is 3.5. And that would be true of both of these over here, 3.5. So I'm going to say pi and then 3.5 squared. And when I do that, I get that the area of the circle is, I'm going to put C here, that is 38.48. Now I also notice I have a rectangle in this drawing. Here's my rectangle right here. And hopefully all of y'all see that the height there is 7, or the width, length, whatever you want to call it. But I also notice that the ends of it are here, so it's not 18. Notice that I've got 3.5 over here, and I've got 3.5 over here. Well, when I add 3.5 to 3.5, that's 7. So to find my width, I'm going to subtract, I'm going to subtract 7 from 18, and that gives me 11. So that means this width here is 11. So again, the area of the rectangle is equal to length times width, which is equal to 11 times 7, which is 77. So then I'm just going to add these two values together. The area of the whole thing is equal to 38.48 plus 77. So that's equal to 115.48. And we're talking about meters squared again because it's area. Number 7, it says find the volume of the figure below. Well, the figure below is a cylinder, so we need to find the volume of a cylinder formula. That's equal to pi r squared times h. Excuse me, and in this problem, we're just going to populate the formula. So the volume is equal to 11 squared times 26 times pi. So our answers are volume is equal to 30,146 pi, or approximately, if we multiply that by pi, 9,883.45, and this would be yards cubed. Number 8 says the volume of a rectangular prism is 655.2 feet cubed. If the base of the prism is 9 feet by 5.2 feet, find the height of the prism. So the formula for the volume of a prism is base times height, and in this case our base is equal to the length times the width, and then we're going to multiply that by our height. So we're given our volume, which is 655.2, and that's equal to our length and our width here, which is 9 times 5.2 times the height. So when we do that, we're going to get 655.2 is equal to 46.8 times the height. And then we're going to divide both sides by the 46.8. So our height is going to be equal to 14 feet. Number 9 says find the volume of the pyramid below. So on this one, again, our formula is volume is equal to 1/3 base times height. And remember, again, this is 1/3 of our base is length times width times height. So we've got our volume is equal to 1/3 of 21 times 9 times 5, which is our height. So when we do that, we get that our volume is equal to 315 yards cubed. Number 10 says a cone with a height of 15 yards has a volume of 457.17 yards cubed. Find the diameter of the cone. So on this one, again, we're looking for the volume of a cone. So that's going to be 1/3 pi r squared h. We're given the volume, so that's 457.17 equals 1/3 pi r squared, and our h is 15. Well, I want you to notice that these two things are on the same side of the equal sign, so I can combine them. 1/3 of 15, or 15 divided by 3, is 5. So when I do that, I get 457.17 is equal to 5 pi r squared. Then I'm going to divide both sides by 5 pi. This is the part where people are messing up the most. When you do this in your calculator, you need to make sure that you put parentheses around that 5 pi, because if you do not, it will divide by the 5 and then multiply by the pi. So you need to make sure that when you divide 457.17 by 5 pi, you do 5 pi in parentheses. So once we do that, though, we're going to get that 29.1 is equal to r squared. Then, of course, we're going to do what we've been doing. We're going to take the square root of both sides to get our r by itself. When we do that, we get that r is equal to 5.39. And here again, notice it's asking us for the diameter of the cone. So we should know that the diameter is equal to 2 times the radius. So 2 times, that would be 2 times the 5.39. So our diameter is equal to 10.78 yards. Number 11. Jack bought an automatic water bottle feeder for his cat. A diagram of the bottle is shown below. What is the maximum amount of water that the bottle can hold? Well, I want you to notice that we have a cylinder up here. That's what this is. So we're going to find the volume of that cylinder. And then we have a cone down here. So we're going to find the volume of that cone after we find the volume of the cylinder. So the volume of the cylinder, that's pi r squared h. So that's equal to pi times, notice that our diameter is 6 here. So if our diameter is 6, our radius is 3. So we're going to do 3 squared times our height, which is 8.5. When we do that, we get that the volume of the cylinder is 76.5 pi, which is approximately 240.33. Then we're going to find the volume of our cone. So the volume of the cone, that formula is 1/3 pi r squared h. Well, again, I noticed that I've got my radius here. That's going to be 3. That's going to be the same as it was before, but I don't have a height right now. But I do. Okay, so out here, notice that the whole thing is 12.5, and this over here would be just 12.5 minus 8.5. So to find the height here, I'm going to do 12.5 minus 8.5. That's 4. So that's my height right there. So when I do the volume of my cone, I'm going to do 1/3 pi. Again, we got 3 squared times our height, which is 4. This is equal to 9 times 4 is 36. 36 divided by 3, this is 12 pi. And then approximately, 12 pi is approximately 37.7. So to find the volume of the whole thing, we're going to add those two things together. So we're going to add together the 76.5 pi plus the 12 pi if we needed an answer in pi, which would be an exact answer. And if we did that, we'd get 88.5 pi, and then our approximate answer, if we were to multiply by pi, would be 270, which we could also do that by adding those other two numbers, the 240.33 and the 37.7. It's going to be 278.03, and all of these answers are inches cubed because, again, it's volume. All right, number 12 says, Cavaliers Principle says that if the height of two rectangular prisms is 15 inches and one has the dimensions of 4 by 6 inches, whereas the other has the dimensions of 3 by 8 inches, what can be said of their volumes and why? Well, the first thing I notice is that 4 times 6 equals 24, and that would be inches squared. And 3 times 8 equals 24 inches squared. So those bases have the same area. So, and it says here that they were both the same height, right? So they were both 15 inches. So what can we say about the volumes? Well, the volumes are the same because the areas of the bases are the same and the heights are the same. Okay, for number 13, a sample of silver had a volume of 150 millimeters cubed and a mass of 50 grams. What is the density of the silver? We talked about this. Density equals mass over volume, and this is a formula that you have to know. So that means all we're going to do here is take our mass, which was 500 grams, and we're going to divide it by our millimeters. So when we do that, we get 3.33, and again, we're going to keep this just like it is right here. So it's going to be grams over millimeters cubed. 14 says, find the volume of a sphere with a circle of circumference of 37.7. So notice this word tells us it's a circle and we have the circumference. That formula for circumference is 2 pi r. Well, we need to use that to find what the radius is because we can't find the volume of the sphere without finding the radius. So that's going to be 37.7 is equal to 2 pi r. Going to divide both sides by 2 pi. And when we do that, we get that r is equal to 6. Then we're just going to put that in our formula for the volume of a sphere. That's 4/3 pi r cubed. So when we do that, we get volume is equal to 4/3 pi, and our r is 6, so we're going to cube the 6. Multiply it times 4/3 and pi. Remember, always leaving pi for last, just in case the answer has pi in it. So that would have been 288 pi. The approximate answer would have been 904.78 centimeters cubed for both. Number 15 says the volume of a sphere is 120 pi centimeters cubed. If the radius is tripled, what do you need to multiply the volume by? One of the things you need to realize here is in a sphere, the radius goes in all 3 dimensions. And so what we're going to do is we're talking about volume, and we know that if the radius is tripled, then all 3 dimensions are tripled. So we're going to pull that tripled number. That would be a 3. And because it says volume here, that's where we get our cubed from. Now remember, if it's area, it's squared. If it's just one dimension, then it stays to the first power. So 3 times 3 is 9, times another 3 is 27. So we would multiply the volume by 27 to get the new volume. Number 16 says the volume of a square pyramid is 532.86 meters cubed. The height is halved. What is the effect on the volume? Okay, so this time notice its height. It's not the height and the other dimensions. It's just one dimension. So it's 1/2. And again, because it's only one dimension, it's not the height, the width, and the length. It's just the height. So we're going to take that to the first power. So that would still be 1/2. So that means it would have become half the size it originally was. Okay, number 17. So 17 says a cone has a height of x meters and a diameter of 2x meters. What is the volume of the cone? Well, our formula for the volume of a cone is 1/3 pi r squared h. It tells me that the height is x, and it tells me the diameter is 2x. Well, we know that diameter is equal to 2 times the radius. We need the radius for this formula. So if the diameter is 2x, and the radius is 2 times, the diameter is 2 times r, we should notice that both sides, the 2's are going to cancel out, so our radius is x. So when we go over here for volume, then we're going to do a 1/3 pi, and we've got our x squared, that's our radius, and then we got our height also that is x. Notice now that we have an x squared times an x, so when we simplify this, our formula is going to be 1/3 pi x to the third. And hopefully you remember that when you have the same basis here with x to the second and x to the first, what are you actually doing? You're going to do the 2 plus 1, so this is equal to 3. All right, number 18, it says find the volume of the given shape. So we have a cone on top and a rectangular prism on the bottom. So I'm going to find the volume of the prism first. The volume of the prism. Okay, so that's going to be base times height, right? Which is length times width times height. So that's going to be equal to 9 times 12 times 4. That's equal to 432 feet cubed. Then we have to find the volume of the cone. Well, the formula for the volume of a cone is 1/3 pi r squared h. Well, I have a problem because I don't have h right now. This is h right here. 7.6 is not the height, it's the slant height, not the height. What I drew in red is the actual height. So I need to use my Pythagorean theorem here to solve for this. And I also know that this is 7.6 over here, so hopefully you can see this triangle I just drew. So we have that this part right down here is 3. So we're going to use Pythagorean's theorem. A squared plus b squared, it equals c squared. So when I do that, I'm going to go ahead and plug these values in. So when I do that, I get 3 squared plus height squared, because this is our height, right, equals 7.6 squared. When I do all of that, I get 9 here plus h squared equals, so this is 57.76. Going to subtract the 9 from both sides. So that would give us 48.76. Going to take the square root of both sides. So our h is equal to 7. So now we do have our height. So we can now bring this down here and finish this. So we're going to have volume is equal to 1/3 of pi. Our radius is 3, so that's 3 squared, and we're going to multiply that times our 7. So our volume here, when we multiply all these together, and remember this time we are going to multiply by pi, is 65.97, and this is feet cubed too. So now what we're going to do is we're going to add together this value and this value. So our volume for the whole thing is going to be 432 plus 65.97, and that's equal to 497.97, and again, the whole thing is feet cubed. So now we're on number 19. It says, what is the cross-section of a cylinder cut perpendicular to the base? Well, perpendicular means that it's a vertical cut. And let's go ahead and go over here, because when we're talking about parallel to the base, that means it's a horizontal cut. So perpendicular means straight up and down through the peak of the, or the top, and horizontal means that it's cut level to the ground, okay? So when we talk about cross-section of a cylinder cut perpendicular to the base, we get a rectangle. When we talk about parallel to the base, we get a circle. When we talk about the cross-section of a cone cut perpendicular to the base, this is going to be a triangle. And parallel to the base is going to be a circle again. When we talk about what is the cross-section of a square pyramid cut perpendicular to the base, this is going to be a triangle. And parallel to the base will be obviously a square, because the base is a square. What is the cross-section of a sphere cut perpendicular to the base? This would be a circle. So would it be if it was parallel to the base? And the last one, what is the cross-section of a triangular prism cut perpendicular to the base? This would be a rectangle. And this would be a triangle, because again, the base is a triangle. Now let me show you what I mean by this. So if I was to draw this triangular, so let's just draw a triangle and a triangle down here. And if we were to start cutting this, we're going to get a rectangle. So in other words, if I were to cut through here somewhere, it doesn't really matter where. If I were to cut through here, we're going front to back, right? So it's going to be like this. So it's going to be a rectangle no matter how I do it. Just smaller or bigger. Okay, on number 20 it says find KL. Well, the first thing I want to notice is that KL is, well, this is a right triangle. So, and I have one angle and one side, so I'm thinking I'm going to use a trig ratio here. So if we look at the sides that we have the side that's opposite, so that's my hypotenuse, and then we have this side over here, which is adjacent. Everybody should know that that's the cosine ratio. So cosine of theta is equal to adjacent over the hypotenuse, and theta is the angle measure. So we're going to do the cosine of 24 is equal to KL over 28. And if you recall, when we have something in the denominator like that, we multiply both sides by it. So what we're going to put in our calculator is 28 cosine of 24, and that's equal to KL. Make sure that your calculator's in degree mode, or it will give you the wrong answer. So our answer here was 25.58. That's KL. With 21, the way I taught this to my students was little triangle over big triangle. So we're going to do little triangle over big triangle, right? Okay, so let's compare. So we've got only one pair of sides that matches, where we have a side of the little triangle. This is our little triangle, right? And we have the side of 10 there, and then we have this big triangle here. And notice the corresponding side of that is BC. So let's just go ahead and write a statement before we proceed any more. So let's just name the little triangle. So we name it A, G, H, and we're going to move the same direction around the other one. So that would be A, B, C. So remember, we can map our letters here. So AG goes over AB, GH over BC, AH over AC. So when we talk about this, we could, if we are looking at GH here, well, look what GH maps to. It maps to BC. So that would be 25. I'm sorry, let me just write BC first. So that's going to be 10 over 25. Then if we talk about this other part that we have here, we have this AG. So AG maps to, first two letters, to AB. So AB, AG was 16 and AB was AB, because we don't have any measure for that. So now we're just going to set those two equal to each other. So we're going to do 10 over 25 and set that equal to 16 over AB. We're going to cross multiply, so that would be 10AB is equal to 25 times 16. That would be 10AB is equal to 400. So AB is equal to 40. Now you should be able to see here that if AB was equal to 40, the way we find GB is simply to subtract 16 from 40. So you should be able to see that AB is equal to AG plus GB, right? So 40 is equal to 16 plus GB, So we're going to subtract 16 from both sides. So GB is equal to 24. All right, so now we're down here on this bottom part. So it says, what is the 3D shape produced when the figures below are rotated around the given axis? Well, this would be a cone. If we were to rotate this all the way around, you should see that it's going to create a round bottom, right? So same way here, if we rotate this all the way around, it's going to give us a cylinder. And if we rotate this thing all the way around, it's going to give us a semicircle, or a hemisphere, sorry. So the last three here says, what is the 2D shape rotated to produce the 3D image? So if we rotate, what do we have to rotate to get a sphere? So basically this would have been a semicircle, right? Half a circle. And if you don't remember these, you need to go back and look at your notes. If we were trying to get a cone, we're going to talk about a right triangle. That's what had to be rotated. And then this should have actually said cylinder here. So I kind of gave it away. So what 3D shape? That was a cylinder. So what should have been rotated to get a cylinder was a rectangle. So now I'm just going to remind you of the formulas that are not on the formula sheet. So when we're talking about area, so the area of a square is equal to the side squared. When we're talking about area of a trapezoid, that one's also not on the formula sheet. This one's equal to 1/2 the height times base 1 plus base 2. And remember that your bases are your parallel sides, and your height is a perpendicular to the base. And then the other thing I wanted to bring y'all's attention to is what is perimeter. This is on the formula sheet on the upper left-hand side, but it basically means when you add all the sides together. So that's what perimeter is. And then also the formula of a prism is not on the formula sheet. So this is base times height. So the question is, what is the base? What shape is the base? So is it a triangle or is it a rectangle? So if it's a rectangle, you're going to do length times width times height, right? If it's a triangle, it's going to be 1/2 length times width and then times height. And then the final one is density. So when we're talking about density, that's equal to mass over volume. So I'm going to go back over this example with you that we did in our notes. So a sphere gas tank has dimensions shown when filled with gas to provide 117 BTUs of energy. To the nearest 10 BTUs, how much energy does 1 cubic foot of the gas yield? Show your work. So again, we need to recall that density equals mass over volume. Well, this is a density problem, and you might not know that by what it's asking you, but I want to point some things out to you. Notice that it says how much energy, and those are your BTUs, per cubic foot. Because there's two dimensions there, we know, or two types of units, that's going to be density. Because if it was just BTUs, or if it was just volume, then we would know that we were trying to find something else, or if we're only given one of them. So basically, the first thing we have to do with this one is find the volume. And we need to just notice here that our radius would be 3, because our diameter is 6. So we're going to do 3 cubed times 4 divided by 3 times pi. When we do that, we get 113. That's our volume. This up here, our BTUs in this problem, guys, that's our mass, okay? The BTUs is our mass, okay? So when we do this, we're going to divide the BTUs by the volume, and we're going to get 1038.9. And again, it says the answer here is 10 to the nearest 10 BTUs. So the answer actually here is 1040 BTUs per feet cubed. So once again, BTUs has to do with our mass. And then our volume obviously is the volume of the sphere, or the volume of whatever shape we're talking about.